One version of integrals that we haven't done with these log rules is definite integrals. So we're going to do 3 examples here, but I do want to point out that generally speaking you're going to need to use a calculator to evaluate these. So I'm going to leave these in what's known as calculator ready form, or in terms of the natural log. So if you want to find a decimal version of this, you're going to have to plug it into a calculator. Anyway, the first one is 3 divided by 2x plus 1 dx. So to do that, we're going to solve it just like we were doing it for an indefinite integral in terms of the substitution. So we're going to let u equal 2x plus 1. So du is 2 dx. So that also tells me that dx equals 1/2 du. Alright, so then what we can do is we can also do the bounds. We can say when x is the lower bound, that tells me that u is 3. When x is the upper bound, that tells me u is 15. So remember, we just plug into this equation to get our new limits. So now what we have is we have an integral that goes from 3 to 15, and we have this becomes a u, and then we have a 3 and a 1/2 du, so that's a 3/2 du. So we can pull out that 3/2. We can say 3/2 integral from 3 to 15 of 1 over u du, which is nice because now when we get the next expression, 3/2 natural log of u from 3 to 15, we don't have to convert back to x's. So that becomes 3/2 natural log of 15 minus natural log of 3. But remember that the log rules tell us that if you subtract logs, you can represent them as a fraction, 15 over 3. So that is 3/2 natural log of 5. So you can do 3/2 natural log of 5, and that'll be your answer. For the next one, we have a bit more of a complicated scenario, but not too bad. It's 2 plus natural log of x over x. So when we're doing this, we say, okay, what I noticed there is this is 1 to e squared of 2 plus natural log of x times 1 over x dx. So if I take this to be u, that will be my derivative. So that's sort of a good indication that we're on the right track. So if I let u equal 2 plus natural log of x, then du is 1 over x dx. So now I'm going to do my bound changes. I'm going to do lower and upper. So when x is 1, u is 2, because natural log of 1 is 0. When x is e squared, if I plug e squared into the natural log, I get 2 times the natural log of e by bringing down the power. And the natural log of e is 1, so u is 4. Again, that's 2 plus natural log of e squared, which is 2 plus two natural log e, which is just 2 plus 2. So just sort of keep it. But anyway, that's just my justification. So my new integral is 2 to 4 of u du, which is 1/2 u squared from 2 to 4, which is 1/2 4 squared minus 1/2 2 squared. 1/2 times 16 minus 1/2 times 4, 8 minus 2, or 6. Okay. And so that's the idea. So we're doing the same thing. We're just applying the techniques for definite integrals here. And finally, we have x minus 1 over x plus 1. Now this one's going to be a little trickier. We could do this with something like long division if we wanted to. Or we could be a little bit clever and go, okay, these have the same power on top and bottom. So if I say that I need x plus 1, but I have x minus 1, then that's the same way as saying that. It's x plus 1 minus 2 over x plus 1, which is x plus 1 over x plus 1 minus 2 over x plus 1. So using that, what we can then do is say, oh, okay, that's the integral from 0 to 4 of 1 minus 2 for x plus 1 dx. Okay, simple enough. So in that particular case, what we need to do is, what I would recommend normally here is splitting this up into two definite integrals. But in this particular case, you can do it as one. But I'm going to split it up into two. So what we'll have is the integral from 0 to 4 of 1 dx minus 2 times the integral from 0 to 4, 1 over x plus 1 dx. Now this integral is just a width of 4 and a constant height of 1, so the area of that is just 4. But then we need to take our u substitution. Well, this is pretty clearly cut that we would take x plus 1. So if u is x plus 1, then du is dx. And when x is 0, u is 1. When x is 4, u is 5. So now what we have is 4 minus 2 times the integral from 1 to 5 of 1 over u du, which then we can take the antiderivative, natural log of u, from 1 to 5. So then we go 4 minus 2 natural log 5 minus natural log 1. But we know that the natural log of 1 is 0. So this is 4 minus 2 natural log 5. And if it were me, I would actually then go 4 minus natural log of 5 squared, 4 minus natural log 25. That's how I would personally write it, but really it's up to you.